If you have ever used an AI coding agent, you know the feeling. You describe what you want, it writes something that compiles and looks right, and then you realize it quietly missed the point. GitHub Spec Kit is an attempt to fix that by making the spec, not the prompt, the thing you build from. Let's break down how it works, what it's good at, and where it falls down. So what's the actual problem it solves? Most people using AI agents today are doing what the community half-jokingly calls vibe coding. You throw a loose prompt at the agent, it generates a wall of code, you eyeball it, and you keep prompting until it seems to work. For a quick prototype, that's fine. But on anything real, a mission-critical feature or an existing code base, the cracks show fast. There's no durable record of what you actually asked for, so every new prompt starts from a slightly different understanding. Concretely, free-form prompting tends to fail in 4 ways. 1. The code compiles but misses the real intent, subtly solving the wrong problem. 2. It drifts from your architecture because the agent has no persistent picture of how the system is meant to fit together. 3. There's no shared context, so 2 developers prompting the same agent get 2 different mental models. And 4. The result is hard to maintain because the reasoning behind the code was never written down anywhere durable. Spec Kit is GitHub's open-source toolkit for spec-driven development. It was created by GitHub's Den Delemarski together with John Lamb, and it's deliberately agent-agnostic. It works with more than 30 coding agents, including GitHub Copilot, Claude Code, Cursor, Gemini CLI, Codex CLI, Windsurf, and Amazon Q. You install a small command line tool called Specify, run Specify in your project, and it drops in a set of structured /commands that walk your agent through a disciplined workflow instead of a single guess. The core idea, the ideology, is intent over implementation. In vibe coding, the code is the artifact you care about and the intent evaporates. Spec-driven development flips that. You write down what you're building and why, in structured, version documents, and the code becomes a downstream product of that intent. The spec is what you review, refine, and argue about. The code is just the current compilation of it. That leads to the mindset shift that makes the whole thing click. The spec is the source of truth, not the code. If the spec and the code disagree, the spec wins, you fix the code to match, not the other way around. Because the agent always reads the same specification, constitution, and plan, every interaction stays anchored to the same intent. That's what buys you consistency across prompts, across sessions, and across an entire team. Spec Kit encodes this as a pipeline of /commands, run in order, with a human reviewing between each. You start with constitution, your project's non-negotiable rules. Then specify what you're building. Clarify resolves ambiguity before you commit. Plan sets the technical approach. Tasks breaks it into chunks. Analyze is a consistency gate. Implement builds it. And converge closes the loop, checking the finished code back against the spec and sending anything unfinished around again. Each step writes a plain file you can read, edit, and version. Let's walk through them one at a time. First, the constitution. This command defines the non-negotiable rules for your project, the principles every later step has to respect. Think coding standards, testing requirements, security constraints, architectural boundaries. For example, every feature ships with tests, no secrets in source, prefer composition over inheritance. It's written once, and constitution becomes the rule set that specify, plan, and analyze all check themselves against. Next, specify. This is where you describe what you're building, the features, the pages, the user flows, and crucially the why behind them. Notice what you don't do here, you don't talk about frameworks, databases, or file structure. Specify is about the problem and the desired behavior, not the technology. For a to-do app, you describe that a user can create, complete and delete tasks, and see them grouped by project without saying a word about React or Postgres. Then clarify. This is the step people skip and regret. Before any planning happens, clarify hunts for ambiguity and open questions in your spec and forces you to answer them. What happens to tasks when a project is deleted? Is there a login? What's the maximum length of a title? Resolving these now, while it's still cheap English, is far better than discovering the gap halfway through implementation when it's expensive code. With an unambiguous spec, plan is where technology finally enters. Here you, and the agent, decide the stack, the architecture, the data model and the key technical decisions, all constrained by the Constitution. This is also where Spec Kit starts generating serious volume. A plan can pull in a data model document, a research document, an API contract and a quick start. Powerful, but keep an eye on it, this is where the markdown starts to pile up. Then tasks. This command takes the plan and breaks it into a numbered, ordered list of manageable, implementable chunks, each small enough for the agent to execute and for you to review. Instead of one giant open-ended build request, you get a checklist, set up the schema, build the create task endpoint, wire the UI, and so on. It turns a big ambiguous ask into discrete, trackable units of work. Before you build, analyze acts as a quality gate. It cross-checks the Constitution, the spec, the plan, and the tasks against each other and flags where they've drifted out of alignment, a task that violates a principle, a plan step with no matching requirement, a spec item nothing implements. It's the automated consistency check that catches contradictions while they're still on paper, before they're baked into working code. And finally, implement. Once you're satisfied with the requirements, plan and task list, you hand it to the agent and it works through the tasks, writing the actual code against everything you've defined. Because every earlier document is still in context, the output stays anchored to your intent instead of drifting. And if something's wrong, you don't just patch the code, you fix the spec and regenerate, keeping the source of truth honest. There's an eighth command most walkthroughs skip. After implement runs, converge asks whether the code that now exists actually satisfies the spec, the plan, and the tasks. It reads the code base as it is, no Git history, no branch diffing, and classifies every gap as missing, partial, contradicting, or unrequested. Then it appends those gaps to the bottom of tasks.md for implement to pick up. It never rewrites your spec and never touches code. When nothing is left, it changes nothing and tells you you've converged. That's the theory. Let's make it concrete with a small, familiar example, a to-do app we'll call TaskFlow, where a user can create tasks, group them by project, and mark them done. Here's what each stage actually produces, so you can see the paper trail the pipeline leaves behind. Setup is 2 commands. Install the specify CLI with UV, then run specify init naming your project and the coding agent you use. Copilot, Claude Code, Cursor, Codex, and about 30 others are supported. What comes back is a .specify folder, a memory directory where your Constitution will live, plus the scripts and templates the commands run on. Your agent picks up the speckit/commands, separated by default, /speckit.specify. Add the skills flag instead and you get the same commands as agent skills, hyphenated. Same workflow, different separator. Everything after this happens inside the agent you already use. The Constitution for TaskFlow stays short and firm. Every feature ships with tests. No secret keys ever land in source control. Accessibility is a requirement, not a nice to have. And we keep the stack boring and well supported. For rules, but every later step now has a bar to clear. Here is the actual transaction. You type /speckit specify, and then plain English, what TaskFlow is, who uses it, what they can do. No framework, no database, no file layout. SpecKit creates a branch, and writes the spec into specs, 001-TaskFlow, spec.md. Behavior, and nothing else. A user creates a task with a title and optional notes. Tasks belong to exactly one project. Completing a task timestamps it. Deleting a project deletes its tasks. Notice what is still absent, any mention of how. Now the plan brings in technology, constrained by that Constitution. A boring stack, TypeScript and React on the front end, a small Node API, Postgres for storage, with 2 tables, projects and tasks, in a one-to-many relationship. This is also the point where, on a real project, you'd see the research and data model documents get generated alongside it. Tasks turns that plan into a checklist. Create the database schema. Build the create task endpoint. Build the project view. Wire up the complete task action. Add the tests the Constitution demands. Each one is small, ordered, and reviewable on its own, no single giant leap. And this is the payoff. One line of the spec, written back when Clarify asked the question. It becomes a numbered task. That task becomes code. When the founder asks 6 months later why deleting a project wipes its tasks, the answer is not buried in somebody's chat history. It is 3 files you can open in a difference you can review. That traceability is the whole argument for spec-driven development. So what do you actually get for all this ceremony? For real benefits. Consistency, because every interaction reads the same anchored context. Collaboration, because that context is shared, not stuck in one person's chat history. Reviewable intent, because specs are plain files you can difference in a pull request. And portability, because it's agent agnostic. Let's take them one at a time. Consistency is the headline. Because the agent rereads the same constitution, spec, and plan on every single interaction, you stop getting the lottery of free-form prompting, where the same request produces a different answer depending on how you phrased it that day. The output aligns to your documented intent, run after run. That reliability is exactly what vibe coding can't give you. The second benefit is collaboration and onboarding. In vibe coding, the context lives in one developer's private chat window. In spec-driven development, it lives in shared files in the repo. A new teammate, or a new agent, can read the constitution, spec and plan and immediately understand what's being built and why. No tribal knowledge, no lengthy handoff. Multiple people can drive the same agent from the same source of truth. Third, intent becomes reviewable. Because the spec, plan and constitution are just marked down in your repo, they show up in pull requests like any other change. You can review a change in intent before a line of code is written, comment on it, request changes, and keep a Git history of how the design evolved. You're no longer reviewing only the code, you're reviewing the thinking behind it. And fourth, it's agent agnostic. Spec Kit isn't tied to a single assistant, it supports more than 30 of them. So your specs, plans and constitution are portable, institutional knowledge you own, not something trapped inside one vendor's tool. If you switch from Copilot to Claude Code to Cursor, the spec comes with you and keeps working. Your investment survives the churn in the AI tooling market. Now the honest part, because this isn't free. Practitioners who've put Spec Kit through its paces report 5 real downsides. It can feel like reinvented waterfall. It generates a mountain of markdown. It's genuinely slower for small tasks. Specs drift out of sync with code. And there's thin guidance for legacy code and mid-project changes. None of these are deal breakers, but you need to go in with your eyes open. The loudest criticism is that spec then plan then tasks then build is just waterfall in Markdown. Write the spec fully up front, then plan fully, then implement. That's the exact rigid sequence Agile spent 2 decades trying to escape. Critics at Scott Logic and elsewhere argue it reintroduces big design up front and that it fights one of AI's real superpowers. That code is now cheap to produce and cheap to throw away, so heavy upfront specification can be the wrong bet. Second, the sheer volume. When Scott Logic ran a real trial, a single planning phase produced a pile of documents, a 395-line data model, a 285-line plan, a 500-line quick start, and a 406-line research document that turned out to be largely duplicative. A lot of it, they noted, was obvious, low-value restatement of the spec. That's a real reading and reviewing burden, and it's easy to rubber-stamp documents you don't actually have time to check. Third, and related, it's slow where speed should be easy. That same trial found they were roughly 10 times faster solving the task with plain iterative prompting than with the full spec pipeline. The general rule practitioners land on, for anything you'd estimate at 2 days or less, the overhead of specify, clarify, plan, tasks and analyze usually costs more than it saves. Spec Kit earns its keep on big, ambiguous, high-stakes work, not quick changes. Fourth, spec drift, the failure mode that shows up over time. Specs only stay valuable if someone keeps them in sync with the code. But the same editability that makes them flexible makes them fragile. Everyone can change a spec, and if nobody owns reconciling those changes, the document and the code quietly diverge. Once the spec is stale, it stops being a source of truth and becomes just more markdown to ignore. It needs real ownership discipline. And fifth, the guidance gap. Most tutorials, including the official ones, showcase greenfield projects, building something brand new from an empty folder. There's much less help for the situations most of us actually live in, making incremental changes to a huge legacy code base, or changing your mind halfway through implementation. Spec Kit doesn't yet have a clean story for mid-flight spec changes, which is precisely where real projects spend most of their time. So when should you reach for it? Spec Kit pays off when the cost of getting it wrong is high and alignment is hard. Greenfield projects where you're setting the foundation. Mission-critical systems where correctness matters more than speed. Teams of several developers who need a shared source of truth. And genuinely complex, ambiguous features where writing the spec is how you discover what you actually want. And when should you skip it? Quick prototypes and throwaway spikes, where the whole point is to move fast and learn. Small, well-understood tweaks that you could just prompt directly in a fraction of the time. Solo experiments where there's no team to align. And exploratory work where you don't yet know what you want, so a rigid upfront spec would just be guessing on paper. It helps to ground this in real accounts. Scott Logic's public write-up, pointedly titled Radical Idea or Reinvented Waterfall, is the most useful skeptical take. They ran Spec Kit end-to-end, hit the markdown avalanche and the 10 times slowdown, and concluded it's powerful but heavy, and easily overkill. If you're evaluating it for your team, that trial is the honest counterweight to the marketing. On the other side, GitHub and Microsoft have published detailed walkthroughs. The official Microsoft developer blog builds a small order summary API end-to-end through the exact pipeline, and there's a free Microsoft Learn module for a hands-on start. And for the legacy question, teams like XP Software have published case studies applying spec-driven development to existing systems, not just blank folders. Read a believer and a skeptic before you commit. If you do adopt it, a few habits keep it from turning into a paperwork machine. Start on one real greenfield feature, not your whole backlog. Keep the constitution short, 5 rules beat 50. Actually read the generated docs, don't rubber stamp them. Assign an owner to keep specs in sync so drift never sets in. And be willing to drop out of the pipeline for small tasks. The discipline is a tool, not a religion. So here's the takeaway. Spec Kit is a serious, thoughtful attempt to make AI-assisted development repeatable, reviewable and shared, by treating the spec, not the code, as the thing that's true. It is not a silver bullet, and it can be genuine overkill for small work. But for complex, high-stakes, team-scale software, writing down your intent before you generate the code might be exactly the discipline the vibe coding era is missing. If clear, sensible thinking is what you are after, subscribing is the most direct way to get the next one. See you in the next video.